The next section of the final involves 3 different ways to solve systems. The first way we learned was by graphing. Here they've given us one equation that is in y equals mx plus b form, but I really want to find the other equation in the same form. So here it says x plus y equals 4. The thing that's out of place is this x. To move it to the other side, I'm going to subtract x from both sides. That's going to give me y equals negative x plus 4. I still have y equals x minus 2. I go to graph these on the same graph. I'm going to put in tick marks every 5 or so. And I'm going to try and be exact as I can. I can always check my answers by putting them back into the equations after I find them. So the first one, negative x plus 4, I'm going to start up at 4. This negative is an understood 1 over 1, so it tells me every time I go right 1, I come down 1, right 1, down 1, right 1, down 1. Sorry, I missed that first one. So right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1. This should be the general direction of that line. The second line I'm drawing is y equals x minus 2. That starts down here at negative 2 on the y-axis. Using that, the y-intercept. There's an understood 1 over 1 in front, so it goes up 1, right 1, up 1, right 1, up 1, right 1. It looks like they intersect at a specific point right here, which is the point x equals 3, y equals 1. If I want to check whether that point actually works, I can plug in 3 plus 1, yes it does equal 4. 1 does equal 3 minus 2. For number 8, it asks me to solve the system by substitution. This is the method where we want to get either x or y alone. It might look like the easiest thing to do would just be to divide this first equation by 3 to get y alone, but actually if I do that, that's going to introduce a fraction here. So I'm going to choose instead to look to the second equation to get x alone. The way I'm going to do it is I'm going to subtract 4y here, subtract 4y here. That's going to give me the equation x equals negative 4y plus 11. I'm going to take this whole thing and put it in wherever I see an x in the equation that I haven't used yet. So that equation that I haven't used yet becomes 3y equals 12 minus 2 times negative 4y plus 11. 3y stays on the left, 12 stays. When I do negative 2 times negative 4y, I get positive 8y. When I do negative 2 times 11, I get negative 22. The like terms on the right-hand side are the 12 and the negative 22. They resolve to give me negative 10. So I have 3y equals 8y minus 10. I now want to take all the y's to the same side. So I'm going to subtract 8y here, subtract 8y here. That leaves me with negative 5y equals negative 10. Last thing I need to do is divide by what's in front of the y. Divide by negative 5, divide by negative 5. That's how I get my final answer of y equals 2. Now I said the last thing I need to do, but really that's not true. Once I get y, I also need to plug it back in to get x. So I'm going to take that y equals 2 into the substitution equation. It's going to become x equals negative 4 times what we found y to be 2 plus 11. So x equals negative 8 plus 11, which gives me a positive 3. Therefore, my final answer is 3, 2. For number 9, it asks us to use the addition method to solve the system. It gives us 2 equations, 2 different ways that I can solve this. Either I can multiply the bottom line by negative 1. That would make this a positive 1x and this a negative 1, which would be equal and opposite. Or I can do what I'm going to do, which is multiply the bottom line by 3. That's going to make this positive 3y and this negative 3y equal and opposite. So if I multiply this whole bottom line by 3, the top line stays as x plus 3y equals 0. The bottom line becomes 3x minus 3y equals negative 12. When I go to combine these lines, x plus 3x gives me a total of 4x. Positive 3y and negative 3y are equal and opposite and go away. This is the key to the step. If I don't have something equal and opposite that goes away, then I've chosen the wrong things to multiply by. To properly do the addition method, I want to make sure one of the 2 variables gets eliminated in this step. On the right-hand side, 0 minus 12 gives me negative 12. I divide the left-hand side by 4 so that I can get x alone. What I do to the left, I have to do to the right. So my final answer for x is negative 3. I can take that negative 3, plug it back into the first equation, and it'll become negative 3 plus 3y equals 0. Add 3 to both sides, and I get 3y equals 3, which means y equals 1. That gives me a final answer of x equals negative 3, y equals 1. Remember that for any of these methods, you can have a situation where you get no solution or you get dependent. If I get two lines that are exactly the same for graphing, those are dependent. If I get two lines that are the same slope and never intersect, that's no solution. If I get an answer that's false, like 0 equals 5 for substitution, that's no solution. If I get an answer that's true, like 5 equals 5, that's dependent. Finally, for addition method, it works the same as substitution. If I get an answer that's true, 5 equals 5, I call it a dependent system. If I get an answer that's false, 0 equals 5, I call it no solution.